Oh, I can't do anything yet.
Okay, and it'll go live to the attendees at the actual scheduled start time, which is in like 16 seconds. So.
Okay, let me get my screen shared.
All right.
Okay, let me put you over on the side and. Okay, can you see my screen?
Yes, sir.
Fantastic. Okay, well, it is 2 o'clock and we are ready to go. This is the Tribal Microgrid Project's successful planning implementation session at the, not the Plans and Environment Forum. I think it's going to be similar to that presentation.
There you go. Just fix it on the fly.
I hope I didn't pull the wrong one because I did actually fix it this morning. And that's spelled right?
Yes.
Okay, well, great. So I'm Josh Simmons with Prosper Sustainability President and Principal Consultant, doing a lot of work with Apollo bands, San Pasquale bands, and also Rincon on various microgrid projects. And so I'll get into some more details in a moment, but Shasta?
Hi, at this point, I think everybody knows me. You've been seeing far too much of me over the last day and a half, but I am Shasta Gaughan, Environmental Director for the Paula Band of Mission Indians. And I've been working with Josh at Prosper for many, many years now. And we've done a lot of work on microgrids, and we're finally getting around to getting our own in Paula. But we've definitely been involved in a lot of the work that is involved in developing a microgrid and partnering with our neighboring tribes in San Pasquale and Rincon.
Yeah, and thanks, Shasta. Thanks for all your support. We've been working together. Well, I mean, we first met back when I was with this environmental director for the San Ynez Chumash, and from 2007 2014, and then started working with Paula Band through Prosper as early as 2014, and just a tremendous job you're doing in all this. I've seen gazillions of emails from you pulling this all together, having to pivot away from Tahoe, which I think was, a sad thing, but looking forward to being out there next year as well, and just doing a really, really amazing job. So thank you for all the hard work that you're doing.
Thank you.
So Josh Simmons, Prosper Sustainably. We started in 2014. We're working with the 3 tribes I mentioned on microgrid projects, discussing microgrid projects with other tribes, doing energy and climate-related planning activities. We are leading the California statewide clean energy and climate change gap analysis project. And if you're on here and you've not completed, your tribe hasn't completed your questionnaire, I'll do a quick plug. It closes tomorrow. So hopefully we will get a few more in and start moving into the analysis phase of that project. John Flores, I don't believe is able to join us today. We'll be talking about the San Pasquale Microgrid project, which is currently in the commissioning phase. And I would love to hear who all's joined. Looks like we have people who've introduced themselves. And also, while introducing yourselves or just at any point, please share what you want to learn about microgrids today. I encourage you to ask questions. I'm happy to steer this conversation in any direction that will be most helpful for you all. I've been involved in a lot of these projects and trying to kind of walk through somewhat of a cradle to grave approach in all this, but I really want to address where you're at right now to help you get your projects up off the ground and into the ground. So we will be covering microgrid basics and then moving on into evaluating and planning a microgrid project, all importantly, getting funding for a microgrid project, constructing and operating a microgrid, and other tribal grid microgrid project examples. So first of all, a microgrid is a group of interconnected loads, with a load being really an energy user. So that could be a facility, it could be a home, a building, it could be an electric vehicle charging station. So a group of interconnected loads and distributed energy resources. And distributed energy resources are different energy resources like renewable energy systems, solar, wind. They could be fossil fuel generators, a diesel generator, a natural gas generator, an energy storage system, really any type of energy system that could be included within this, connected to the interconnect to the loads within a clearly defined electrical boundary that acts as a single controllable entity. And in this case, we're talking about a grid connected microgrid. So with respect to the grid. So that was probably a lot right there. I'm going to step back and try to simplify that. Actually, let's just show, this is not necessarily a simple example, but I'm going to try to walk you through this. So let's say we have number 6 down here represents, let's say that there's 3 of these buildings right here. And this building is being, all these buildings are connected, and they're being served by these diesel generators over here. So there's 3 big diesel generators. There's solar over here, and there's centralized controls. And here's the grid. They're all connected to the grid, but these systems are all electrically connected and controlled at a single point of interconnection, and that allows the wind resources, the diesel generation resources, I think these are maybe batteries down here, all those resources can be directed as desired to serve the series of facilities that they're connected to, both when they're on the grid. And so if they're on the grid, you're usually using them to reduce your energy costs. So you do demand charge reduction and what's called energy arbitrage, or really storing power that you're buying that's cheap, such as solar or grid power when it's cheap, and then using that stored power when energy is more expensive, so you're not buying it from the grid. So that's what you do in on-grid mode. And then when the grid goes down, this microgrid, the interconnected loads and distributed energy resources that are interconnected and controlled are able to remain online, and you can continue to use these generators, the solar and the wind, the batteries, to keep these facilities operational if you're experiencing, say, public safety power shutoff events, which I think a lot of tribes throughout California are experiencing. So the types of applications are really, I think first and foremost, keeping essential tribal facilities online. And actually, I would encourage you to share some applications or potential applications you're considering. With Paula, we are working with Shasta on a series of individual microgrid systems serving essential government facilities, such as the fire station, the admin complex, the wastewater treatment plant, tribal law enforcement, utilities, tribal services, and others. For San Pasqual, there's the microgrid that's in the commissioning phase right now, is serving the whole government campus. At Rincon, we're working on 3 microgrids, one for the government center, one for the fire station, one for the resort area campus, which includes Harrah's wastewater treatment plant and a travel plaza. So really, it's the things you want to keep online during an outage are the things that you're going to need to include in the microgrid. And ideally, your microgrid is also going to provide economic benefits, allowing you to reduce your energy costs. But that may not be the primary purpose. In a lot of cases, it's not the primary purpose for a microgrid. It's first and foremost keeping those facilities online when the grid goes down. You also, right now we're talking about a grid connected microgrid, but you could have a separate a non-grid connected microgrid, so that's completely separate from the grid. You may have a series of facilities that really you have your own generation resources that are powering these facilities, the homes, the buildings within your community, that you don't ever connect to the grid, and though you're solely relying upon those resources to keep your facilities online. So it's basically a permanent island. So a microgrid, usually when it goes off the grid, it's called islanding. And so if your microgrid's not connected to the grid, you would have a permanent island. So Shasta, I don't know if you're able to monitor some of the questions, or
Yes.
if something comes up along the way, and let me know at appropriate times if it seems like a good time to address some of them.
Well, I'm just going to give you a few examples of what people are talking about. Terry McCartney from Hopland is saying they have some solar on their housing, but they would like a microgrid, and they already have 3 Tesla backup batteries and 3 diesel generators for use during public safety power shutoff events. So definitely interest in using existing facilities to to develop more. And I asked her what facilities. It's the wastewater treatment plant, the administration offices, and the COVID relief center. So Terry, quick question out loud. What funding did you use for that? Because for COVID relief, I'm gonna assume it was CARES Act funding. So you can answer that in the chat, and I'll let Josh continue.
Yeah, and one thing I also want to kind of point out, provide a distinction is there may be backup generators for certain facilities. There may even be batteries at certain facilities. There's a lot of money through the CPUC self-generation incentive program, the equity resilience budget, for even free energy storage systems for homes and facilities on tribal lands. So you could have a battery keeping your home online. You could have a backup. You could have a diesel generator or propane or a gas generator that kicks on when the power goes out. And a microgrid is really going to be like a series of resources. So you could consider a microgrid to be if you had a generator and a battery that you were able to use at the same time to keep a single facility online. Or if you had a series of generators and a series of batteries and say a solar system, you can fully connect those and fully control those to keep one or more facilities online at the same time. So it's going beyond kind of a single backup power system for a single facility to multiple facilities and or multiple distributed energy resources, forms of generation that are going to keep those facilities online. Okay, so first and foremost, you're going to need to consider your microgrid related needs, goals, and objectives. Why do you want a microgrid? Is it because you're experiencing public safety power shutoff events? Your critical facilities or homes are being shut down, losing power for hours, days, weeks, and these facilities and buildings and homes need to be able to continue to have power. Is there are you seeking economic benefits? Are you seeking to reduce your energy costs? What are those critical facilities as well? That was talking about the applications themselves. So there, those are kind of some of the primary objectives. We'll get into some more, but first of all, just kind of ensuring that you are considering your goals and objectives ensures that you actually are pursuing a microgrid for the right for the not necessarily the right reasons, but for appropriate reasons. Microgrids can be expensive, and you want to make sure that the investment is being made that's actually going to address the needs that you have. So, what are your power supply threats, PSPS events, fires, extreme storms, brownouts? How long and how frequent are your outages? If they are shorter duration, then microgrid itself may not be as essential. What essential community facilities need power? Do they have backup power, and what capacity? How much power is that backup, say the generator or that battery providing, and then for how long? So for a diesel generator, it's a combination of what is the the kilowatt or megawatt capacity versus the load. How much of the load can it serve? And then for how long? So how much diesel do you have available for you to keep that facility online? Is it an hour? Is it a day? Is it a week? And you got to consider, okay, well, how much backup power do you have right now, and for how long? How much of the facility it's covering? And then how long are your outages? So if the backup power right now is adequately covering your facilities, keeping the essential facilities online during an outage, then you may not need to consider a microgrid. But let's say you have, some have backup generators, some don't, and or those facilities just are not. You have a day's worth of power, but the outages you're experiencing are days or weeks long. Then at that point, you may need to consider either scaling up that backup power or considering a microgrid system. So this is a picture Shasta sent me a few months ago of Gregory Mountain on fire, and just an example of what it's just a day in the life of a Californian. And so these things are affecting tribes and really everybody across the state on an ongoing basis. But tribal communities tend to be more rural areas, tend to be not as connected, tend to be the first closer to where the fuels are for these fires, and tend to be the communities that are hit hardest by the public safety power shutoffs to prevent, which has not really been very effective, prevent these fires from happening, the grid de-energization, and then the fires themselves, and they do occur. So part of the impetus for the San Pasqual microgrid project was the wildfires that they've experienced. This is a bit of a dated map. I'm sure there's more fires that they've experienced more recently, but just large swaths of territory surrounding the reservation experiencing wildfires for the past few decades. So wildfires and go hand in hand with high winds and de-energization. Usually it's the red flag days of high winds that lead to de-energization to avoid wildfires, which still seem to happen anyways. We're experiencing, it seems to be, at least since I've been living in California since early 2000s, extreme storms are happening more regularly, more intensely. There can be planned outages that occur as well by utilities, and then it could be accidents. Like hit a pole, and you experience an outage for hours or more. And these are resulting in outages of days and even weeks, resulting in lost productivity and revenues, and the inability to use facilities and to have critical services be available to community members, both kind of for their regular purposes, but also for their emergency purposes. And then you also can have equipment that's damaged as well. So for the San Pasqual microgrid project, the three primary goals were, first and foremost, resilience, being able to maintain electric power during outages. Closely behind that was reducing electricity costs. So, how you design your microgrid, what resources you include in that are going to either potentially improve or decrease the economics of the project. And then another main goal of the tribe was to decrease the environmental impact of trying to achieve 100% renewable energy and reduce greenhouse gas and other air pollution emissions. So after considering goals, needs, and objectives, you'll want to move into, and if you haven't already started that, your feasibility study and preliminary analysis. And I want to say this is an iterative process. I think there should be an ongoing conversation with respect to needs, goals, and objectives. So you don't necessarily need to draw a line in the sand at the beginning, but continue to revisit those, and some of those may change along the way, and even in the future after a microgrid's installed, some of the needs, goals, and objectives may change, and the functionality of the microgrid or the facilities they serve may change as well. But the feasibility study and preliminary analysis are really leading to determining whether or not the project's feasible, but also defining the scope of the project itself. And that will involve gathering site information and data, particularly load data. What are the load needs? What is the energy load? What is the peak power needed by the facilities? What is the annual energy consumption? Are we talking about just electricity? Are we also talking about are we also talking about gas powered HVAC heating systems as well? And whether those should be included too. And then what facilities? What are those critical facilities? What are those critical services? What are those what homes are you seeking to include within this project? For San Pasqual, the facilities are the Tribal Administration Building, which serves as a Red Cross Evacuation Center, Public Emergency Center, and really the Emergency Operations Center for the tribe. Housing and Security houses their public safety departments, which has cameras throughout the reservation, and they're part of the first responders on the reservation, as well as the fire department. And the Education Building and preschool serve as additional emergency public shelters, particularly for families and children. And then actually, I think it's not included at the final design did not include the wastewater treatment plant, but initially we sought to include the wastewater treatment plant. It does have some backup power, and I think there's a certain amount of time that the facilities can run without the wastewater treatment plant being operational. And you'll go through the process of design, engineering, even construction, and at some points you may discover that it can be too costly to include certain facilities or meters, and so you may need to kind of adjust the scope. So you will start off with what's the best case scenario, what are the ideal facilities and loads you want to include in your microgrid. And then as you proceed through your design engineering, get cost estimates, and even proceed into construction, you'll have to make adjustments potentially. So the initial design for this project was a 160 kW solar PV system, a new tied, and also including an existing 24 kilowatt system on the education buildings, propane generation, both new and there's some existing propane generators, battery energy storage system, a 2-hour battery at 150 kilowatts, microcontrols, and energy management controls. And you'll see how this changes. So, that was our initial scope for this project. We worked with San Pasquale on securing project funding, and we pursued DOE grant funding, as well as I believe there was a grid alternatives grant that was received as well for this project. Included some potential funding sources for this. I think the pretty typical one is the Department of Energy's energy deployment grants. They do have technical assistance that can support that. They have a loan guarantee program, which I'm not actually sure anybody's ever successfully used. The BIA can fund the feasibility studies for these projects. So the energy minerals development program grants actually were part of what were used by Paula and working with Paula to do feasibility studies and initial planning for the series of microgrid systems that we've secured DOE grant funding to actually deploy. The resilience program grants, the BIA potentially could be used for some level of planning. Those are typically focused on kind of climate change adaptation resilience planning, but I think this is very much related to resilience. And they have some technical assistance I have not necessarily successfully used. I'm familiar with, USDA has a series of grants, and they're kind of, those opportunities are kind of evolving. I don't have direct experience with USDA grants, but I would keep your eye on those, particularly if you've had success in using any of these funding sources in the past. We've secured California Energy Commission grants for projects. For the Rincon project, we've secured a $7.2 million grant for about 10 megawatt hours of long duration storage capacity in combination with a DOE grant. Some tribes across the state have been successful in securing the Strategic Growth Council Challenge grants. And that's not necessarily going to be a recurring funding opportunity, but I believe that there is going to be additional funding coming through both CEC and Strategic Growth Council for tribal projects. So I'll keep your eyes on that. What I'm finding right now is, aside from the BIA Energy Minerals Development Program grants, it's difficult to find funding to plan these projects, to do feasibility studies and I'm hoping that the state, working on the gap analysis, and I think that's will be one part of the findings we present, is hopefully getting more money to support the feasibility studies, the planning and pre-development activities to really get these projects to be shovel ready, so that they can then secure DOE grant funding to be implemented. Some other things to keep your eye on: the FEMA BRIC, building resilient infrastructure.
And communities.
Okay.
I think. I don't know. Everybody put in the comments. Put in the comments what you think BRIC should stand for.
So that one, I believe it's potentially, you could potentially receive microgrid related funding. I'll just leave it at that. There's an evaluation process about cost effectiveness, and sometimes it's hard to have a microgrid compete against a backup generator. But I think it's something they're, within the scope of what they're seeming to try to fund. I don't have any experience or haven't pursued that BRIC for that. But that's that's a recurring funding source. And actually, I believe tribes have pretty much a guarantee with a 25% cost share. Tribes have almost a guaranteed amount of money through the BRIC program. I think at least $500,000, maybe, or at least at last go around, I think it was $500,000 to $600,000. So, and at that point, it's not competitive. So long as it's eligible, if you want to use that to support funding a microgrid, then that could be a good route to go. I mentioned other ones as well. Also point out tax equity financing. We are working with pursuing tax equity financing for the Rincon project. So in that case, we have 2 DOE grants, $5 million in CPUC SCHIP rebates, a $7.2 million CEC EPIC grants, and are also all within the umbrella of a tax equity financing partnership with a tax liable investor who can take advantage of the investment tax credit and depreciation and flow some of those revenues to the tribe. So, we're talking about a pretty large scale project there. But that can be the difference of these projects being feasible or not, or it can allow you to scale the project. For the Rincon project, we initially got $2 million DOE grants. We then pursued the CEC funding, got the additional $7 million, and then we pursued another $1 million for a separate microgrid for the government center. And then the cost share reduction opportunity gained another $1.5 million. And then all of a sudden the equity resilience rebates, SCHIP equity resilience rebate opportunity presented itself for, in the $5-6 million range. And so it's one of those things where if you build it, they will come. And then on top of it, there's an opportunity to expand the solar. So the tax equity financing itself allows us to get more funding without actually, the benefit of tax equity financing is that the tribe can get additional revenues from the project and actually just not have any upfront costs. So they can actually repay the financing with energy savings through a PPA, a power purchase agreement at a set rate, which is hopefully less than what the tribe would be paying for energy already. And so it's essentially, it kind of serves as both a loan, but also bringing additional revenues to reduce the cost of the project for a tribe.
So I'm going to jump in here for a second just to say that this can all probably sound really overwhelming to people who have not tried to pursue any of this type of funding. And I'll say that it does take somebody with some know-how to get through these grant proposals, because unlike some of our tribal specific funding from EPA, for example, something like a brick application is pretty complex, and the Department of Energy applications for sustainable energy or for any energy, like the one that we just received for this year to put our microgrid in at the Paula administration and other facilities, it requires an understanding of how to look at your data, how much energy you're using, how much is going to be offset by using solar instead. There's a lot of different things. So I'm just going to say that if you're feeling overwhelmed by it, don't be afraid to reach out to a professional, a consultant, somebody who can help you do it and do it right. And if it's done well, you're going to really increase your chances of getting that funding that can be used to help offset the cost of hiring somebody to help you. And I'm saying that just because I did not have the ability on my own to do these grant proposals. It was just, I have too many other things on my plate. So just remember, there are people out there who can help you with this, with technical assistance, with grant writing. So don't let the scariness of it or the unfamiliarity of a lot of what you're hearing, don't let that scare you away from trying.
Yeah, and I think hopefully, I think if you can get grants like the BIA Energy Minerals Development Program grants, you can get funding to essentially prepare the grant proposal. That funding
Right.
to do a feasibility study. And a lot of times on the projects I'm working on with Paula, San Pasqual, Rincon, and other tribes, it's just like we're actually using planning dollars and feasibility dollars to develop grant proposals because it's the same process. You are developing the project concept, you're determining the feasibility, you're laying out the analysis for the project, and it's more productive if you're doing that in the framework of a grant proposal, which you can deliver and get funding for the project. We have a session going on tomorrow about energy planning, and it's like we can do lots and lots of planning, but if it doesn't result in actual things in the world that are going to that are the things you're planning for, the benefits you're trying to achieve through the planning processes, then you're just kind of spinning your wheels. And so you want to kind of try to be thinking ahead, as don't do the planning just for the planning. Try to, if you're pursuing a planning grant, try to actually have, let's say, the DOE grant in mind, and use the planning to develop a plan and develop the application pieces, you already need to prepare for the DOE grant, which is a recurring funding opportunity that has 10, 20 plus $1 million per year available for these projects.
Yeah, and remember too, in your gap grants, under some of the capacity indicators, one of the capacities that we are trying to develop is the ability to get future funding for these projects. So you can put that in as we're going to look for, we need some money to do the process of getting a grant to start to implement or explore some of these options.
Yeah, so we definitely spend a lot of time on the funding piece, but I think it's a critical, a really critical piece, just because it's the difference between these projects being successful or not. If you did enter at the stage where you were able to secure some funding, likely you're not going to conduct your project procurement until after. I have a link here on these slides, which will be made available to the San Pasquale Tribal Government Complex RFP that went out. It's still live, so you could use that as an example. Your own, and that's probably may go hand in hand. You may do some, likely some preliminary design and engineering will need to be done in order to develop an RFP for this type of project. But usually you'll do more detailed design engineering. That scope will be in the RFP itself, and you may have a single group doing all of it. You may break it up and have design engineering done by initial group, and then another team build it. But the design engineering phase is going to include considering the design of the project, develop engineering all the electrical components and structural components of it. You'll initiate your permitting, your interconnection application, and all of that. So this is an image of the initial conceptual design for the San Pasquale Tribal Government Complex Microgrid project. And so this doesn't necessarily need to be done by an engineer per se. In fact, I think I developed this with the support of somebody else, maybe Michael Burr. But he's not an engineer either. This is just these are the meters, and we had to explore where solar could potentially be installed. But the concept is that these 7 meters will all be electric connected and connected to the distributed energy resources throughout this campus. The new solar over here in the carport solar, the existing solar on top of these rooftops, the diesel generators that are over here, and a little harder to see, this is actually the energy storage and controls system. So that was the initial design. So as I mentioned, we ended up ultimately having to remove the wastewater treatment plant from it. As we went through design engineering, the actual, I think the solar PV system size, I believe, went down. The energy storage went up because of the the SCHIP equity resilience rebate opportunity, which was going to fund a 4-hour battery at peak. So that was great. And then we decided that it wasn't cost effective to pursue kind of full campus energy management controls. Instead, we just focused on kind of installing some Nest thermostats throughout various facilities to at least allow some greater control over HVAC in particular. Your heating, ventilation, air conditioning systems tend to be one of your largest subloads within your facilities that are important to be able to control, making sure that when the grid goes down, it comes back on in the middle of the summer or the fall where it's 100 degrees out, that all your HVAC isn't coming on and ramping up at the same time, because that influx of demand all at once could actually shut down your microgrid, because you may not or quickly drain the capacity you have on your battery. You want to be able to control that to a certain degree. We also identified the opportunity to install some electric vehicle charging stations, wasn't part of the initial design as well. So then if you've gotten to that phase, you've designed and engineered the microgrid system, hopefully you've still determined to be feasible and cost effective, and you're proceeding into the construction, commissioning, and deployment of the microgrid system. We are in the commissioning phase. For San Pasquale, the microgrid is fully constructed, and the commissioning phase is just where you test it, make sure it works the way it's supposed to work, and then after you've gone through a period of testing, operational testing and outage testing, both in on-grid and off-grid modes, then you be prepared for the full interconnection and deployment of the microgrid system. So here is a screenshot of the energy storage systems, the batteries for the San Pasqual microgrid, and a picture right next to the nice view from the tribal police department. And an earlier image of the carport solar that went on the northwest side of the campus. So after the system's deployed, and you certainly need to be thinking about this earlier, is the ongoing operations and maintenance of the system. So you want to consider who's going to perform the ongoing operations and maintenance. There is a significant amount in a microgrid system. They're complex because you're seeking to control so many different things, and those controls require a significant amount of both hardware and software solutions to be implemented and managed. So you're likely going to need to have a group that's at a minimum managing the software on an ongoing basis to ensure that the microgrid itself is operating in both optimally in on-grid and off-grid mode. It's able to be adjusted when things like rate schedules from your utility provider change, so that you continue to optimize the financial benefits of the project. But also, you want to have somebody who's going to be available to monitor the system, going to perform some basic maintenance. If something's not functioning the way it's supposed to, that can quickly get out there and address the issues. If there are warranty issues that occur, they'll support you in that as well, to ensure that your system has, is going to actually be operational, available when the grid goes down. If you don't have kind of an O&M, likely you'll pursue an O&M agreement, maybe with the installer of the system itself. You could potentially assume some of this on your own, say cleaning solar panels. You may have some engineers on staff. Most tribes won't be able to assume these responsibilities. So there's an ongoing cost to this as well. So you need to factor that in, not just the cost of designing, engineering, constructing, and deploying the facility, but the ongoing cost of operations and maintenance. And that should be considered upfront in your feasibility study and preliminary analysis, what those costs may be, so that you're projecting the annual and full project economics at year 10, annually, but particularly at year 10, 15, you're going to have to replace inverters, but probably your batteries. The solar itself is going to last hopefully 25 years or more. So, you want to model at least 25 years in these projects. I think I'll just kind of breeze through these other ones, and then we'll kind of circle back to questions. So this is a simpler microgrid, the Rincon Fire Station, that's going to have some carport solar in combination with an existing diesel generator and some backup batteries. The Rincon Government Center microgrids, the solar plus storage plus diesel generator, some electric vehicle charging stations are on site. This is a newer facility. In this case, we found that the diesel generator actually was a little bit on the smaller side. It's just large enough to cover the full load of the facility as it stands right now. But the facility only came on. This facility was built in 2018, and it's not really at full capacity. But the generator was actually only wired to serve a few parts of the facility. So microgrids will include rewiring that generator to serve the full facility, as well as the solar and the battery serving the full facility online, both on and off grid modes. And this is the highly complex Rincon Harris microgrid project that I was talking about before. That includes about 10 megawatt hours of flow and flywheel energy storage systems, which are emerging long duration energy storage technologies. This says 0 to 1 megawatt hours. I think we're probably looking at more like 3 or 4 megawatts of lithium ion batteries is where we're at right now. We're at the kind of middle of the engineering design phase of this project right now. We're probably looking at 4 megawatts of diesel generators. So again, this was the preliminary design, and you get into the preliminary design, you start to dig in, and you find that things change, and in some cases they're going to be more expensive. In some other cases, it may be, maybe we can reduce some costs. One challenging part to this project in particular is that COVID has led to supply chain issues that have increased costs across the board for everything, costs of steel and other major commodities that are, we had some initial costing for this project that it's in of itself, without increasing the size of some of these systems, is already increasing the cost of the project. But fortunately, there's enough revenue streams for this project to still make it viable.
And how complicated can it be? It looks, those are all just Legos, right?
Yeah.
Yeah. just snap some Legos together, and your flywheel energy storage Lego, and you're good to go.
Yeah. So I also want to, not to make it seem more complicated. The controls piece of these projects are really, really critical. And the ability of the controls to speak to all the different resources is not a guaranteed thing. So just because you have a bunch of generators and even a bunch of batteries, maybe solar there, doesn't mean that you can just slap in controls that easily can speak to these things. And maybe that those generators are too small, or they don't have the software systems themselves or hardware to support or be integrated within a microgrid system. So it may be that you have resources that you want to include, but you can't include, at least as of right now, or it would be extremely expensive to design and engineer and develop the software to actually include some of these resources as well. So it's really the controls piece, and having somebody who really understands that at these stages is a really critical piece that, has been emphasized to us. We have a technical advisory committee that includes Blue Lake Rancheria and UCSD and Miramar Air Force Base, and among others. It's really an all-star team, and they've really, highlighted some of these important things and shared some of their experiences on what's really critical to the success of these projects. I think this is the kind of the final example for, we'll dive more into questions. This is the we've worked with Paula to secure DOE funding for a series of the microgrids, they're solar plus storage plus diesel generator systems. So this isn't going to be a single microgrid serving all these facilities. They're going to be separate systems. In this case, for the admin campus, it is going to serve at least the admin and fitness center, as well as the whole parking areas. The radio station will be separate, but excited about getting this project deployed as well, and exploring other opportunities potentially to even expand, let's say, the solar to fully serve the loads as well. Okay, so I know there's been a lot of questions. I'll start scrolling through, but maybe Shasta, you can help me triage some.
For sure. So we had a question from Robertson Chatlin Jr. He wanted to know about grants available for wind turbines on tribal lands, and I answered in the chat, but you might be able to expand. I said, yeah, there's going to be sustainable energy grants for things like turbines, but I think another question to go along with that is, can wind turbines be used as part of a microgrid?
Yeah, absolutely. I'm not, most of the microgrids I've worked on have all included solar, but wind is a major renewable energy generation resource. Like it's, if you're, Paula, San Pasqual, Rincon, and Southern California, the wind resources aren't great there, but solar resources are phenomenal. But some of the tribes, you go a bit further east, and wind makes more sense than solar. So absolutely, wind would be a great resource to include in a microgrid system.
And we also have Andy Bessler is here from the National Tribal Air Association, and he added a link in the chat about NTAA's new policy tool for California tribes to benefit from CARB's SEP program, which I can't remember what SEP stands for. Sustainable Energy Planning, maybe something like that. Yes, Andy? But so that's a helpful link. And the NTAA has been great about a lot of these sustainable energy initiatives because they improve air quality and reduce greenhouse gas emissions. So thank you for that, Andy.
Yeah, in terms of resources, one thing I'll point out too, as part of the California Tribal Gap Analysis, we have been developing a grant opportunities database. We're going to directly send it to those who completed the questionnaire, but it's currently available on our website under the last webinar, where we have on here 130 something resources for tribal climate energy projects, federal, state, otherwise as well. And so this could be a good resource to go to identify some funding resources for microgrids and other projects you're considering. And let me drop that the link. Drop that link in the
Drop that chat in the link.
yeah, something.
Trust me, I think all of us are speaking in tongues these days. But Andy clarified it's the Supplemental Environmental Projects is what SEP stands for. And for any of you who are from Arizona and Nevada, this stuff applies to those states as well from a federal standpoint. We have a lot of information about California just because that's where we are. And California has been on the leading edge as far as providing funding opportunities through their self-generation incentive program, their SGIP, which we're taking advantage of. But all of our states are, high sunlight regions, and there's a lot of capacity for wind energy as well, or even hydro. But I want to note also in Northern California, where there may not be as much sun, we haven't explored this very much, but there may be more possibilities for geothermal energy, especially along the Sierras or in the very southern part of the Cascade Range, which is a volcanic range. And so there's going to be a likelihood for, or a possibility for geothermal, which is essentially using the trapped heat of the earth to generate power.
Yeah, and I definitely don't have any direct experience with geothermal. I'll also say that, there's kind of active geothermal systems that can generate energy. There's also passive geothermal systems that, really are available most places just because the steady temperature of you go down a few feet and you can use it for kind of supplement heating and cooling for any home or facility in most areas. But you usually need to better to actually install it before the building's built.
Yeah, and let me qualify what I said too about hydropower, knowing that hydropower generally involves damming a river, which has all sorts of ancillary environmental effects. So I'm not advocating for, for big dams. In fact, I would advocate more for the dams disappearing. But there are other ways to leverage smaller hydropower systems than damming rivers. But yeah, obviously for us in our region, sunlight is going to be the most abundant energy source. And hopefully as time goes by and the technology improves, even in the lower sunlight regions, there'll be the possibility of capturing and storing energy as batteries also become more efficient and being able to, over time reduce our reliance on fossil fuels and create more sustainable energy. And then I also want to note, because earlier on in the chat, now I can't remember who said it. I think it was Terry from Hopland. I asked where the funding came from. I said I thought it might be CARES Act funding. No, she said it was from PG&E, Pacific Gas and Electric. So, sadly, some of that money is available because PG&E basically set the state on fire a bunch of times. And so now they're having to provide money to mitigate some of those impacts, especially for public safety power shutoffs. But that's something else to explore. If your local utility has funding available, then that's another way to consider getting some funding to help you with these projects.
I see a question. What about future farming? I'm wondering if you can elaborate. That was, I guess, funding for future microgrid to support future farming. I mean, certainly a microgrid could support ag-related operations to the extent that they're energy, energy intensive.
Well, and we saw there was a presentation right before this one from the Augustine Band of Kauai, and they have gardens growing around their solar energy installation, and so they're kind of doing it both ways. So rather than just letting that area where they've installed a bunch of solar just go to waste, they're making gardens around that. So they basically have agriculture and solar all on one piece of land. So that's great. That's something else to consider. Have your farming fields, they can still be active and you can put solar on them at the same time. And maybe that even provides some shade for some of the more heat and sunlight sensitive crops. So there's a lot of different ways to do this to kind of cross the streams as far as different needs for your tribal community.
Yeah, I mean, I'll just say it too. I know cannabis is something that some tribes are considering as well, and very energy intensive. So I mean, any kind of greenhouse operations that are requiring supplemental heating as well would be something worth considering it for.
We have several cannabis sessions, 3 different cannabis sessions during the conference that have more to do with pesticide applications and how they may have off offsite impacts because of cannabis grows that are taking place near tribal lands that end up affecting water and things like that. Right now, EPA will not allow us to do any sort of commercial cannabis agenda items because it's still illegal from the federal side of things. So nonetheless, we snuck some cannabis agriculture and hemp stuff in there because it does have an effect on the environment. But it's a good point, not just hemp or cannabis, but there's a lot of energy intensive crops that require greenhouses. So there's no reason not to put those two things together. And Heidi wanted to know who's farming under solar. It's the Augustine Band of Cahuilla out in Riverside County in California.
Yeah, and actually, related to ag too, just there's the energy water nexus. I mean, it requires a lot of energy to pump water, and so we're seeing some of these types of facilities, distributed energy resources, battery, solar, and others to support water pumping, particularly in remote areas where it won't be a grid connected system. You just need that. Another thing too we're seeing is a lot of telecommunications facilities being cell towers and other facilities needing solar plus storage backup generator systems to ensure that there's connectivity for remote communities.
Yeah, and Josh added a copy or a link rather to the California Tribal Gaps Analysis Program database for California tribes. But there's some, or correct me if I'm wrong, Josh, there's some resources in there that are eligible across. There are federal resources. It's not just for California. So it's useful for all of you to look. And I'm going to also add that to the documents for this session. And just FYI for our attendees, any of you can go back to a session that's already ended. Just make sure that you click the little tab on the agenda that says show past sessions. You can go to those sessions, you can watch the recording, and you can also have access to any documents like presentations and things that were added to that session. So that's where I'll be putting these things. And Josh, we've run out of time. So it's not going to kick us out until I hit stop broadcast. So if you have any final thoughts, now's the time.
Yeah, I've been excited to work on these projects and make them actually work for the tribes in multiple respects. But happy to continue to share our experiences, hopefully at future events as we get further along. And I wish you all the best. I didn't provide my contact information in the slide, so I just said in the chat. But thank you, Shasta, for joining me, and thank you all for your time. Can you answer a question about GAP? I don't know if we have time for one final question, or is that it, Shasta?
What's the quick question about GAP? Robertson, if you want to go ahead and type that in, or better yet, if you have a GAP question, I would put that into the main lobby chat because there's all sorts of GAP experts here. So that's where I would go to deal with that question because we're out of time and I got to jet off to a 3 o'clock session. So
yeah, thank you, everybody. Really appreciate you all participating.
Thanks. Bye.
Take care. Bye.